So the last but not least, Julius Denafas will give us the presentation about SoliTek R&D, from SoliTek R&D, sorry, about solar technologies of tomorrow. So what are you researching? Can you tell us?
I will try. Okay, so thanks for your patience, and I'm happy to make a closing presentation of our conference. So yeah, as you heard in the beginning of this conference, SoliTek R&D is part of the SoliTek family, and we started as a solar cell production team, but now we do more things and we focus more on the research. Not the laboratory level research, but more industrial level research. So that's what I want to talk a little bit about today. Yeah, so outline of my presentation will be to talk a bit about activities. Majority of our activities are based and actually partially funded by European projects. I will talk a little bit about maybe most interesting results which we have up to date. So I will talk about module performance, recycling, reliability result, and because we have nicely presented the new product, the battery, the SoliTek battery, so we also have an R&D project going about that. So I also want to say a few words about new project for us. Yeah, so main activities of our team is, of course, to support our production team with daily technological quality issues. So we try to give our insights, maybe do additional measurements to help improve the product quality. In our R&D time, we work on the module and system level innovation. So we focus on increase of yield. We are also focusing on digital operation and maintenance and benchmarking of different module technologies. We're very active in circular economy in PV. We have already second project about that. New focus area not only for SoliTek from commercial point of view, but also for our R&D activities is storage and EV charging solutions. And yeah, one more maybe activity where we are involved with our partners and let's say friend companies. So development and performance of monitoring of new cell module technologies, including IBC, flexible and lightweight PV. At the moment, we have 5 active international projects. Some of them are very close to at the end, but some of them will continue for the next couple of years. So Super PV highlights Circusol and Greenest. So you can see the topic. I will not go into a lot of details about these projects, but basically they are about reduction of LCOE through technological innovations and operation and maintenance digitalization. We work on the novel solar cell module manufacturing processes. We work on the circular business models for PV industry, and as already mentioned, on innovations related to green energy generation, storage, and by combining that, creating solutions for e-transport. I'm also, sorry, not that, oh, this direction. I'm also happy to announce that we will have one new project which has already been granted and will start by end of this year. So we will collaborate mainly with our partners from Sintef, Norway, and we will contribute to the development of PV thermal facet elements. So this was a long time ago that we wanted to try this area and try to make some developments, but finally we will have a chance now to do that. So this is just to give you an idea that what could you expect from us during next meetings, during next presentations to talk about as well. PV thermal means that we will include electricity and then heat generation in the same panel, and they will be tested on real buildings. I have to mention PV IPSI because you already heard it 2 times from Ivan and from Žygimantas, but I would also like to mention because SoliTek is leading one of those projects, so PV IPSI for the integrated solutions. So as you already heard, this project has kicked off. Of course, the funding is not yet secured, but we are preparing for that. And our project target includes, let's say, several main goals. So we want to develop and create mass production of BIPV and infrastructure integrated PV products, so 1 gigawatt. We want to scale up mass production of IBC solar cells based on Zebra technology, so 500 megawatts. We want to develop and create mass production of unconventional OT4 modules for vehicle integrated PV, also 500 megawatts. We also have a goal to implement fully automated flexible PV manufacturing line, meeting the Industry 4.0 standards. And the last goal is to establish a sustainable infrastructure for certification and testing of integrated PV products, which is, we think that but let's say European PV producers really need that, and they are lacking these testing facilities. So basically, 4 factories for different products and 1 testing center we would like to build and run through this project. Okay, now let's go to some results and come back to our, let's say, a bit smaller activities, what we do more on a daily basis. So we started one project, Super PV, in 2018, and finally after a few years we have some interesting results from SoliTek module performance in various climate conditions. So basically we and our partners, we build, how to say, mirror demo sites in various climate zones, so hot and dry locations in Morocco and Tunisia, hot and wet locations in Seville, Spain, Rabat, Morocco, and cold and wet, let's say, demonstration site and climate conditions in Vilnius and Oslo. In order to compare how the panels perform in different climate conditions, we set up a similar data collection equipment in every demo site. So it includes dust sensor, pyranometers, albedometers, climate station, temperature sensors on the panel, TIGO optimizers for monitoring every panel individually, data logger, and then collection of data. In addition to that, our partners from Spain and Switzerland, they developed a digital twin model for every demo site. So here is a screenshot of Vilnius demo site just to show the main idea of it. So basically we have a 3D model of the building, of the surroundings. We have a 3D model of the demonstration site with all the panels inside. And here we have the curves. And in these curves, we have power generated, which is measured by inverter or by TIGO, for example. And we also have the simulated energy curve. And we have also climate data. So what this model is doing is takes the online climate data from the demo site. It puts that into model, and it gives the output, the predicted output. So the main idea is that if there is a big mismatch between the calculated output and the real output, then we can look directly into the problems. And since we are monitoring every panel individually, so we can even start seeing which panels are underperforming, and then we can go and take a look. So the main idea, when this tool will work nicely, will be troubleshooted fully, is to offer it as a operation and maintenance tool for the PV plant owners, and basically to speed up the process of troubleshooting and of course increase the yield. Quickly, what kind of panels we have installed. So I will focus only on SoliTek modules in this presentation, and we have monofacial, we have bifacial, we have bifacial panels with some innovations, let's say, or some improvements. So 2 improvements are coatings, so they are hydrophilic and hydrophobic. That is to increase the anti-soiling properties and self-cleaning properties. Then we have a reflector. So reflector means that we have a white color printed on the rear glass between the solar cells, so to increase the internal reflection. And one more innovation is the laminated bypass diode. So this is what we are testing in these demo sites. Now, very quickly, some short videos about every demo site, and I hope I will manage to run the video. Maybe not really. Yeah, okay, now it's running. So yeah, these are short videos, 1 minute, but I will show you several different locations. So this is Oslo, Norway. SoliTek modules, CIGS flexible modules as well installed there, and also crystalline silicon modules from Apollon Solar. So Apollon Solar is not anymore in the business, but they developed interesting, but unfortunately not successful from commercial point of view technology for the solar panels. This is a solar panel which doesn't have any encapsulant inside. Yeah, so just a quick overview how the demonstration site looks. It's a rooftop installation. The panels are bifacial, and the mounting system, as you see, is elevated. It has a certain height above the roof, so it also helps with the albedo, increase of albedo effect. Yeah, we also have demo sites in desert conditions. So one of them is in Tozeur, Tunisia. Hot climate, sandy, but also interesting, I think, location. And here's how our small demo site looks. The panels are ground mounted. They have this portrait orientation, and the mounting system is also optimized for bifacial technology, so that there is a minimum shading on the rear side. So there is also a room for all the inverters and data loggers computer for data collection and analysis. So basically, in every demo site, we use the same type of inverters, the same, optimizers as you already saw, in order to have as equal comparison as possible. One more demo site in Morocco, it was actually used not for the comparison of bifacial module technology, but testing power electronic devices, but it was just want to show that where we are testing our panels and where that we are not only in our country, in our factory, but really with the help of this project, we expanded a little bit our geography where we are doing some research. So, of course, don't evaluate these installations like from professional point of view. These are some people did it for the first time, for example, in this particular case. So it's also learning. So we are also educating people there. So, but yeah, that's part of also these research projects. We were a bit surprised that why they haven't cleaned our modules, but I hope they will do it. When we need to send them a message to say. Okay, so quickly, I want to present the results just in the, let's say, measured energy yield differences and at these locations. So I take bifacial as reference, and then basically the numbers mean that we took generated kilowatt hours during that period, and we just saw which group was better or worse. So we see that clearly, just one more time confirmation that bifacial works basically in all cases better than monofacial. The highest number we saw, it's 18% difference in Tozeur in the sandy conditions. In Oslo, we have some maybe issues with the data collection, so at the moment it's still under analysis, but in Vilnius demo site, for example, we have 9% gain comparing bifacial and monofacial. So yeah, the laminated diodes, no gain. Actually, this is not a big issue because the main purpose of this experiment was to test if these laminated diodes are reliable, but maybe this time I don't focus on that. And we see that reflection gives additional from 1.5 to almost 4% gain, depending on the location in energy generation. Hydrophilic coatings, they work nicely in most of the demo sites except Vilnius. So here we saw no gain, and we are actually analyzing why. And the hydrophobic coatings, also in 2 locations, we haven't seen any gain, and we saw up to 3.5% gain in hot climate, in sandy climate. So, so this is on top of the bifacial gain plus this on top. So it means that we can, how to say, even more expand increase the performance of bifacial models with this kind of improvements. It was not planned, but it happened in this project a little bit by accident that we tested one of the SoliTek solid bifacial model in the humidity freeze test, and we tested it for a really long time. And the outcome is quite, I think, interesting, and we can just confirm one more time that our models are reliable. So, you know, humidity freeze is part of the standard certification procedure, and it asks to run 10 cycles. We did 500 cycles, and we lost about 2.4% in power only, with minor visual defects as well. So this is to show you that these models can really withstand the harsh conditions a lot. One more image also to show the glass maybe disadvantages is that also the dam heat testing. So EL images before and after dam heat, and this is after 3,500 hours. Also, we saw a little bit of maybe darker areas in EL image, but no major damage. So again, very reliable modules, and standard requirement for such tests is 1,000 hours. So we pass these things easily. Yeah, the last, I'm going, approaching to the end of my presentation. So, of course, I still want to mention the recycling. One slide about that. In a couple of projects, we have partners who help us to recycle our panels and to analyze the possibilities to recover materials. So I hope that some of these processes will be used in the future recycling factories of SoliTek as well. But the main idea, what I want to show, that technology developed by LuxChemTech, we recycled the glass backsheet module, and we were able to extract glass unbroken. We were able to extract silicon, Templar, EVA, and also ribbons. So this is based on the water jet treatment. So basically the water jet is cutting layer by layer the panel from one side, and in this way you can control which layer you want to recover. But of course it's still a lot of research is ongoing, especially on the glass module level, how to separate it, how to recycle it without maybe losing too many materials. The work is ongoing. Yeah, and then a few slides about this new battery project, so which started recently, and we are actually very happy that we are able to work on it, because it's really a source of knowledge for about the new technologies for storage and electric transport. We are collaborating in this project with partners SINTEF from Norway and PROTECH from Lithuania. And yeah, it's funded by MITA, by the Agency for Science, Innovation and Technology. And it started last year in July and will last until April 2024. Activities, so SoliTek is responsible for developing EV charging stations and new generation autonomous bus station. PROTECH is responsible for lightweight PV modules and folding PV power plant based on those light PV modules. And SINTEF will test these products under Nordic conditions, or these prototypes under Nordic conditions, and of course will do a very important task, so assessment of recycling of these technology. So quickly, what we mean by autonomous bus stations. So we were really thinking what to do, and actually we had a meeting with Vilnius City Public Transport Department, and we just scheduled. We now have a meeting in October, and they got really attracted by this idea, and they promised to give us a space, a bus station frame, so that we could play, we could integrate our products, and we could test the performance. So it will be really a real prototype, not something, you know, calculated or small scale but real functional bus station. The idea is that it will have a battery, it will have PV modules, it will have charging points for small, let's say, electric vehicles like scooters, bikes, and or mobile phones. Yeah. Also, an interesting part of activities is this is so-called battery buffered mobile EV charging station, ePitStop. We call it like this. The idea is that will be a product optimized for use in locations with a weak grid connection, or let's say where, which means that not only the grid connection is weak, but also the investment to provide enough power, let's say, to have high charging capacities is really big. And yeah, we will build two prototypes, single and three phase. The first prototype will look pretty simple. It will be a cabinet with all components inside, like batteries, inverters, charging controllers, and there will be also charging cables attached. So yeah, the phase at the moment of this project is that we are simply buying components, and most of them they were delivered. We are waiting for some small elements to be delivered, and the assembly will start still this autumn, and we hope to start testing it in the first quarter of 2023. Yeah, but the main idea that it will also use, it will be able to have a connection from the PV for the charging, and also to the grid as well. And our partner is PROTECH, so they are developing the flexible PV portable system. Yeah, the video works. So yeah, the main idea is that it should be also combined, if needed, with our portable or mobile EV charging station. So we're focusing on that. And also in this flexible system, the lightweight PV modules should be integrated. And lightweight means that they will be based on polymer lamination, so ETFE, PET with back layer. So currently development is ongoing on mini module level, and you see that there were hail tests already done, and the EL images before and after. And yeah, so currently development is ongoing, and during next year we will definitely have some larger scale prototypes, which we will integrate into the further testings. Okay, with that, yeah, I would like to thank you. That was a quick overview about our current R&D activities. Thanks a lot.